Aryan,
Present, ma'am.
Vaishnavi. Vaishnavi has left the university or what? Huh?
Ma'am, 748
Ma'am,
ma'am or 747 ma'am, दोनों present है
ma'am,
ma'am.
7:48 I got disconnected. Cloudy weather.
You will tell
Ma'am,
me last at last. Let me complete first. At the end you will tell me. Okay. Last class what I have completed, tell me.
Ma'am, phase algebra applied to RL
Ma'am,
series.
Tell.
ma'am, 744 you haven't marked me present.
Okay. At the end you will tell me. I will do it.
Okay, ma'am.
So what I have completed, tell me.
Ma'am, phase algebra applied to RL series circuit.
Phasor algebra applied to RL
RL
series.
series circuit, yes, ma'am.
RC series circuit also I have applied.
What, ma'am?
Or I have, RC series circuit I have completed. Phasor algebra applied to RC series circuit.
No, ma'am. No, ma'am. Only
Only
RL.
RL.
Yes, ma'am.
Okay. So next come to phasor algebra applied to RC series circuit. Now first one question you tell me why you are applying phasor algebra. What is the importance of applying phasor algebra to this series circuit, AC series circuit? Tell me, I have told you last class. Applied to RC series circuit. What is the importance of, without phasor algebra, you have already solved circuits, RL series circuit, RC series circuit. What is the necessity of using phasor algebra? Yes, tell me. Tell.
And we can say whether it is resistive circuit, inductive circuit by only seeing phasor diagram. We don't
Yes.
need to calculate each and everything.
Yes, good. You can know the circuit condition. Okay, by solving, suppose the value of the resistance, inductance, capacitance value is not given. From voltage and current, after solving, you can able to know whether the circuit is purely resistive or the circuit is purely inductive, or what is the condition of the circuit, whether it is only inductive. Okay, pure resistive 0, pure inductive 90°, pure capacitive 90°. But if you are getting less than 90°, voltage is leading than current compared to current, then that is a inductive circuit only. It's not pure inductive circuit. Okay. So from last class I have done one example related to RCC RL circuit. There I have told you I have not given any information about the resistance and inductance, but from the circuit condition after solving you are able to get it. You can solve the circuit easily by using phasor algebra. That is the only intention of using phasor algebra to the AC circuit. By using phasor algebra, you can able to solve the circuit very easily. Okay. Now come to applying phasor algebra to RC circuit. So this is a resistor connected in series with a capacitor. This one is your R, this is C, this is VR, this one is your VC, and this RMS value we are representing as capital letter, that is your capital V. Okay, all the letters, all the voltages I have denoted it as capital letter. That means they are all RMS value. Okay. So here, so the RMS value of the current is I, capital I. So now at every instant, your V will be, supply voltage will be equal to how much? Your Kirchhoff's law voltage law is valid. So V will be equal to VR plus VL. Sorry, VR plus VC. So here Kirchhoff's law is valid, but here we are not taking the algebraic sum like what we are taking it is in case of DC circuit. Here we are taking the phasor sum, right? So here, due to the presence of the resistance, in this case, your current will be in phase, or the voltage across the resistor will be in phase with the current. So the phasor of VR and I is like this. And due to the presence of the capacitor, the current phasor is like this. The voltage will be, what will be the condition of the voltage? This one is, yes, 90 degree lagging the current. So this one is your current phasor. The voltage is lagging the current by an angle of exactly 90 degree. Okay, so if I will draw all the phasors, this is your current phasor, this one is your voltage across the resistor, that is your VR, and this one is your voltage across the capacitor, that is your, I am putting it as minus VC because that phasor we are showing it in the downward direction. Okay, so here, so now if you'll find out the resultant, this one is your VR plus VC phasor, this one will be your what? V. Okay, so now here you tell me, run it, this one. Okay, do it.
Ma'am, why minus PC?
Because that is in the downward direction. Yes. Run it.
Yes, ma'am.
I'm done.
Okay. So here how we will represent this vector I, how I will write down in the rectangular form. I will be equal to how much? I, just wait 1 second, let me close the board and again I will open it. Just wait 1 second. Now it is visible, see?
Yes, ma'am.
Yes, ma'am.
Okay. So here, now how I will write down this phasor I? Listen to me carefully. So how I will write down this phasor I, current phasor? In the rectangular form, can I write down as I plus how much? J0. All of you got it?
Yes, ma'am.
In the polar form, how I can write down? In polar form, how I can write down? Tell me. It will be I at an angle, how much? 0 degree? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So now this V is equal to, you know that this V is equal to how much? V is equal to VR, I can write down in the rectangular form as how much? VR is equal to how much? I into R. So this one I can write down as IR plus J0. Now in polar form, how I can write down? Polar form, I will write down IR at an angle, how much degree? 0 degree. Got it or not? Why? Because the phasor VR is in the same phase as that of the current phasor. Got it or not? All of you got it?
Yes, ma'am.
Ma'am,
Tell.
ma'am, how it is saved? It
is
will be
same.
like
Tell.
90 degree, no, ma'am.
How? VR and I are in same phase. VR and I are in same phase.
Okay, that one. Okay, ma'am. Okay, ma'am.
Yes,
Yes,
I am explaining the only phasor VR. Okay.
Okay.
So now come to VC. Is in which direction? VC is in, I am talking about only VC. VC is in downward direction. Okay, so how I will represent it as this one magnitude is your VC. I will write down as minus J into how much?
V.
J into not V, VC. Yes or no? So this will be equal to how much? This will be minus, what is your VC? VC is equal to how much? I into XC. Understood or not?
Yes.
So minus JI into XC. And got it, all of you? Got it? Okay.
Yes.
All of you got it, or is there any doubt? Tell me. Understood, all of you? Yes or no?
Yes, ma'am. Yes, ma'am.
Okay. So here, how I can write down as this one is your VC is equal to I into XC. So this will be equal to how much? JIXC, because that vector is rotated how much degree? 270 degree from its reference axis. So I have to multiply minus J. Understood or not? Got it, all of you? So this will be equal to, all of you got it or not? Tell me, respond, all of you. So this will be equal to how much? Respond, all of you. So this will be equal to how much? Tell me, 0 minus how much? Yes, tell me, 0 minus how much?
J square into
Tell.
J square into JIRC. Means that J cube हो जाएगा मैम या J square.
270 degree when you are rotating, how much you have to multiply?
J cube.
J cube is equal to how much? J cube is equal to how much? J cube,
JIR whole की power.
J cube is equal to how much?
Minus J ma'am.
Minus J.
That's only I have multiplied. Okay, J cube is nothing but your minus J. So I have multiplied with minus J. Minus J into how much? VC. Clear? J has no relation with the magnitude. J is multiplied implies that that vector is rotated 90 degree from its original axis in anticlockwise direction. Right? Similarly, when you are multiplying minus J when it is multiplied with a vector or phasor, that vector or phasor is rotated 270 degree from its original axis in anticlockwise direction. Got it now, all of you?
Yes, ma'am.
Okay, all of you understood, or again I will repeat?
Ma'am, again repeat.
You have forgotten phasor algebra?
No, ma'am, not forgotten.
So here my vector is, this one is what? This one I am not multiplying anything.
No,
This
ma'am.
is I
I.
implies it is I at an angle 0 degree.
Good.
Okay, that is equal to, it has no imaginary component. This is I plus J0. Understood? When a vector is presented in this direction, that is last class I have told you, that is your VL. That is your VL. So what I will multiply? I will multiply, have to multiply J when I am representing in the phasor notation. So this is equal to how much? Ji into how much?
XL.
Understood?
Yes, ma'am.
When I am representing in the downward direction, what I will multiply?
Ma'am,
Minus J into
by
VC. Understood?
Yes, ma'am.
Okay.
Yes.
Now it is clear to all of you?
Yes, ma'am.
All of you, okay. So now here what I have done, I have one phasor in this direction. This one is your VR. This one is your minus of what? VC. Okay. So this is your capital V. This angle is your what? Theta. This is clear to all of you?
Yes, ma'am.
Now, yes. So VR, how I can write down? This as IR plus how much? J0. This is clear. Step by step I'm asking. Is it clear to all of you?
Yes,
This
ma'am.
one? Okay. Then VC, how I will write down? Tell me. VC will, how I will write down? Tell me. Minus J into how much? IXC. This is clear?
Yes, ma'am.
So this I can write down this as 0 minus ji into xc. Clear to all of you? Clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Still, I need some more answer. Anybody having
Yes,
doubt? Tell
ma'am.
me. Okay. So V is equal to VR plus VC, that is equal to IR plus J0 plus 0 minus JIXC. Now you are clear? Clear?
Yes, ma'am.
Any doubt up to this?
No, ma'am.
Any doubt up to this? Tell me.
No, ma'am.
Okay. So this is equal to, so this implies V is equal to I into R minus JXC. Okay. So from, this is from voltage triangle, we have got, this is from the voltage triangle, and from impedance triangle, how I will draw, this one is your R, and in the downward direction will be your XC, but I will write down here minus XC, and this one will be your what? Z. Clear to all of you? So how I will write down this one? R phasor, how I will write down? R can be written as R plus J0, or in polar form it can be written as R at an angle 0 degree. Yes or no? Got it?
Yes, ma'am.
Got it? All of you got it?
Yes, ma'am.
Yes, ma'am.
Okay. Now you tell me XC, how I can write down? I want to write down the vector XC. How I will write down? Tell. Tell. How I will write down?
0 minus JXC.
0 minus JXC. Very good. Okay. So now here, how I will write down your Z? Z, how I will write down? Z is equal to R minus how much? JXC. But the magnitude of the Z will be equal to how much? Magnitude will be
Under
constant, R square plus X square.
ZX.
Understood? All of you? Clear now? Is it clear to all of you?
Yes,
Yes,
ma'am.
ma'am.
Okay. So now, and what will be the value of the theta? Tell me, what will be the value of the theta? Theta will be equal to tan inverse of how much? Minus XC divided by R.
R.
This is your theta, right? Clear? Anybody having doubt up to this? Tell me. Anybody having doubt up to this? Tell me. No doubt?
No, ma'am.
Okay. So now here I will tell you why, what is the necessary of using this phasor algebra. See, listen to me very carefully. I have told you I can write down current if I know that is your J plus J0. I am taking it as the reference, that is I at an angle 0 degree. Z I will write down, this is R minus JXC, that is equal to Z is present at an angle how much? You look at your voltage
Theta.
impedance right now. Yes, at an angle how much degree?
Theta.
Theta. But I have told you it is, this one is your lagging, this one is your leading. If I am taking this one as theta as positive, okay, theta is positive, here what I will take? Negative. Yes or no? Yes or no?
Yes, ma'am.
Got it or not, all of you?
Yes, ma'am.
All of you got it or not? Yes. So when I was taking, listen, when I was taking this one in the case of inductive case, what I was taking? This one was VL, this one was VR, this one was VL, here, this one was V. Here I was taking as the theta, theta is positive here. Okay. When I'm considering VC, this one is your VR, this one is your minus of VC, this one is your theta. Here theta will be what? Negative.
Negative.
Understood now, all of you? All of you are clear? Raviraj, Rishabh, clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, respond. Otherwise, I'm not getting. If you are sitting silent, I think that many of you are not able to understand. I am worried about that. Okay, so now I is equal to I plus J0. That is your I present at an angle 0 degree because I is in phase with the VR in both the cases. Whether it is in, this is in case of RL circuit, this one now I am explaining in case of RC circuit. Okay, so what I will write down in polar form, Z at an angle, how much degree, tell me? Z is present at an angle, how much degree? This is for voltage diagram. If I will draw for the impedance diagram, impedance triangle, this one will be your what? R, this one will be your XL, this one will be your Z. Yes or no? Tell me. Theta. Already I have done it. No need to draw once again because I am unable to move the board. So again and again I am drawing. No need to draw it. Everything I have done it. So in this case, this is your R. This one is your minus XC. This one will be your what? Z. This angle is your theta. Yes or no? So Z is present at an angle how much degree? Yes, tell me. Z is present at an angle of how much degree?
Tan
Yes.
inverse.
And theta.
It, why tan inverse? I want how much degree it is present. How much degree? Tell. By an angle theta, but I have told you in which case you will take it as positive, in which case you will take it as negative.
RL positive and
RL positive, RC you will take it as negative. So what you will write down here? It will write down at Z at an angle minus of theta. That means from the reference axis, this is my reference axis, this Z is present at an angle of how much? This is Z. This one is your R. Yes or no? Yes or no?
yes, ma'am.
Got it, all of you? All of you got it? Or is there any doubt or any repetition you want? Tell me. Tell. Understood all of you or not?
Yes, ma'am.
Yes, ma'am.
So theta here, I am taking it as negative. In this case, I am taking it as positive. In case of inductive case, I am taking it as positive. Here theta is positive. Here theta is what? Negative. Because this one is my reference axis. This one is my reference axis. Am I clear now, all of you? All of you are clear?
Yes, ma'am.
Okay, very good. So now I have got the value. All of you have written, drawn it?
Ma'am, 1 minute, ma'am.
Okay,
Ma'am,
right.
1 minute.
Right. Anybody having doubt, tell me. Ankit,
Yes, ma'am, understood.
understood? Dono Ankit Saran,
Yes, ma'am,
Ankit
understood.
Senapati. Okay, very good. When I will do problems, I will do many problems, don't worry. Your concept will be completely clear. Written?
Yes, ma'am, written.
Yes, ma'am.
Okay. So now here you see Z is present at an angle of minus theta. Now suppose this one, these two information is only given to you. I information is known to you, Z information. Suppose this information, forget about the RC circuit or RL circuit or RLC circuit, it is given. In your question, only current and impedance value is known to you. This much. Forget about I am teaching about the RC circuit. These two things has been given to you. Okay. So now what you will do it is, you can find out the voltage. Voltage is equal to how much? I into Z. Okay, I need which operation? I will do the multiplication operation. So what I need? I want to, if it is in the rectangular form, I have to convert it into polar form for doing the multiplication operation. So I have the polar form. So what I have to, I will do I at an angle 0 degree multiply with Z at an angle minus theta. So this will be equal to IZ at an angle how much? 0 plus minus theta is equal to how much? Minus
Minus theta.
So V is equal to Iz at an angle of minus theta. That means this is what? This is your magnitude part, and this one is your which part? Angle part, right? So now if we will compare with the current one and the voltage one, here you see, this is my voltage, this one is my current. What you conclude from these two, tell me? I is present at an angle 0 degree, V is present at an angle, magnitude is your Iz, and it is present at an angle of minus theta degree. Obviously, theta is less than 90 degree. If then what you conclude from this? What you conclude from this two? Tell me. Tell.
Voltage lags current.
Voltage is very good. Who answered?
I'm Vaishnavi.
Very good. Voltage lags the current by an angle of how much degree?
Theta.
Or current leads the voltage by an angle of how much degree?
Theta.
Clear to all of you?
Yes, ma'am.
Okay. If I have told you, written all of you? Written?
Yes, ma'am.
Yes, ma'am.
Okay. So I have told you, listen to me carefully. Each steps you understand properly, then you ask if you are having. I have told you in the question, suppose I and Z is given. Suppose in the question B and Z is given. Suppose in the question, I will do it for one problem, then I will. Then you will able to understand, otherwise you will confuse you. Okay. So from here, from this, you are able to conclude that voltage is lagging the current or the current is leading the voltage by an angle of theta degree. Now we will apply phasor algebra to. Now we will apply phasor algebra to RLC series circuit. Make a heading. This one you will tell me. Phasor algebra applied to RLC series circuit. This one is your last circuit. Phasor algebra applied to RLC series circuit. Now here, this one is your resistor, this one is your inductor, this one is your capacitor. This one is just supply voltage V. This one is your current I. This is RLC. This is your VR. This one is VL. This one is your VC. Now you will tell me here. I will not do, you will tell me whether you have understood or not. What is your voltage? How I will write down this voltage? Tell me. Tell. Voltage, how I'll write down? Tell me. Tell. You write and tell. How I will write down the voltage? Voltage is equal to, supply voltage is equal to how much? Tell me. Supply voltage.
VR plus VL plus VC.
Okay, yes, VR plus. And now I have already drawn the voltage triangle. Yes or no? I have already done the voltage triangle for RLC series circuit. This one is your VR. This one is your VL. This one is your minus of VC. What will be your this vector? This vector is your VL minus VC, because here I am taking a condition that VL is greater than VC. I am taking the voltage across the inductor is higher than the voltage or greater than the voltage across the capacitor. So here the resultant voltage will be in this direction. Yes or no? This angle is your theta, right? This one I have drawn it. Yes or no?
Yes, ma'am.
Okay. Now impedance triangle, this is my voltage triangle. This is your voltage triangle. What you have understood, I will ask you now. Voltage triangle. Now impedance triangle, I have also drawn the impedance triangle. Have I drawn it or not? Tell me. This
Yes,
is
ma'am.
R. This one is your XL. This one is your minus XC. Minus means it is downward direction, nothing else. Okay, and this one will be your XL minus XC.
Minus XC.
Okay, very good. Then this one will be your
Impedance.
this
Z.
one is your impedance Z. Very good. Okay, this is my which triangle? This is my
Impedance triangle.
impedance triangle, right? So now from this one, what is your supply voltage? Tell me. What is your supply voltage? V is equal to how much? This one from the voltage triangle, tell me. V is the addition of which two phasor? VR
VR plus
VL
minus VC.
VC phasor. Remember that VL minus VC I am taking because I have assumed that VL is greater than VC. Okay. So VR plus VL minus VC phasor will be equal to the supply voltage, right? So VR, how I will write down? VR is equal to I into VR is equal to IR. How I will write down VL minus VC? VL minus VC will be equal to how much? Tell me. Quick.
Ma'am,
It will be
minus
You tell me first, VL minus VC is in which direction? Is in the upward direction?
Yes, ma'am.
Yes or no? Upward direction means it is rotated how much degree? 90 degree from its original axis. Yes or no? So
Yes,
this
ma'am.
will be equal to how much? This will be equal to, yes, tell me.
Ma'am, J.
J, how much? J, how much? Tell me. VL is equal to how much? Let it be wrong. I want how much?
XL
I into XL minus
Minus
how much?
I into XC.
All of you got it?
Yes, ma'am.
All of you understood or not? Is it difficult?
No, ma'am.
No difficult at all. J into why J? Because the resultant is, look at the
90
resultant
degree.
vector. It is 90 degree from its reference axis, right? So VL minus VC, I will write down this one. So V will be equal to how much? V is equal to I into R plus how much? J I into XL minus I into XC. Understood all of you? So this is equal to I into how much? R plus J XL minus XC. Got it up to this? Anybody not able to understand? Tell me.
Yes, ma'am. Got
Anyone?
it.
Anyone you have not understood? Tell me. Anyone you have not understood? Tell me.
Understood, ma'am.
Got it all of you?
Yes, ma'am.
Is there any? Okay. So this one will be equal to how much? This one will be equal to I into Z. Z is equal to how much? Tell me. Z, that means Z is equal to R plus J into XL minus XC, right? Okay. Yes or no?
Yes, ma'am.
Look at your impedance triangle. Look at your impedance triangle. Impedance triangle, is it correct or not? Tell me.
Yes, ma'am.
Yes, ma'am.
Okay, so V is equal to I into Z, where Z is equal to R plus J. But what is the magnitude of the Z? Magnitude of the Z will be equal to how much? Tell me. These are all phasor. Okay, what is the magnitude of the Z? It will be square root of how much?
R square plus XL minus XC.
XL minus XC whole square.
This one is your magnitude, don't forget. That is in the phasor notation, we are writing the Z phasor as like this. What is your theta? Theta will be equal to how much? Tan inverse
Tan
of
inverse XL minus
VL
XL
minus
minus XC.
XL minus VC.
VC by R.
BC divided by VR.
VR.
VR, na?
Yes, ma'am.
So this will be equal to how much? Tan inverse of tan inverse of XL minus XC divided by R. Okay? Clear to all of you?
Yes, ma'am.
Okay, so now come to the polar form. Like how we have solved it. Up to this, anybody having doubt, tell me. Let me ask. Anybody having doubt, tell me. Ritankar, you understood?
Yes, ma'am.
Okay, very good. Polar form how I can write down? तुम तुम्हारे सर्किट देखो, you see your circuit और ऊपर नीचे में नहीं कर सकती हूँ. See your own circuit. Tell me. I is equal to how much? I plus J0 in the rectangular form, in the polar form. How I can write down? I at an angle 0 degree. Is it correct or not?
Yes, ma'am.
Z is equal to how much? Z is equal to simply R plus J XL minus XC. Z is present at an angle how much? Tell me. Z is present at an angle how much degree?
M theta degree.
Theta degree. Plus theta will write down. Plus theta. Because there is a condition of minus theta. I will
Yes,
tell you
ma'am.
that later. Okay. So V is equal, because RLC when you are talking, there may be a condition that XL is greater than XC, or there may be a condition that XL may be less than XC. I have taken only one condition where XL is greater than XC. Okay, so that's why I am putting a plus sign. Understood all of you why I put a plus sign? Minus sign I will explain. So that's why I put a plus sign. So V is equal to how much? V is equal to I into Z. Suppose in the question, let me ask you that this I is known to you, Z is known to you. So voltage is equal to I into Z. So I at an angle 0 degree, I need a multiplication operation, Z at angle plus theta. So this is equal to IZ at an angle how much?
Theta.
Plus
Theta.
Theta. Plus theta.
So from here you can able to know that V is leading the current by an angle of how much degree? Theta degree.
Theta degree.
Understood? Understood? Clear to all of you or not?
Yes, ma'am.
Okay, this is your suppose case 1. Case 1, I am taking VL is greater than VC. Now suppose I will tell you a case 2 where VL is less than VC. Then my current is equal to I plus J0, that is I at an angle 0 degree, same thing. Z will be present at an angle, Z value is R plus J, how much? R plus J or minus J?
Minus XL.
Tell. You tell me. Now you apply your brain and tell me. I will drop it now. Here in the case 2, suppose I have taken VL less than VC. Then what will be my condition? My resistance will be like this one. Okay. In which direction your XL and XC will be present? Tell me. XL is less than or VL is less than VC. That means my VC vector will be more. Understood
Yes,
or
ma'am.
not? Tell me.
Yes,
VC will be more than how much? VL.
B.
So VC minus VL will be in which direction? All of you please be attentive and listen properly. So this will be VC minus VL. Very good. So now this one will be what? R plus VL minus, VC minus VL will be equal to how much? Tell me. Is equal to V. Understood all of you? Clear to all of you?
Yes, ma'am.
So this one is your, bolo. Questions? Pucho.
Clear, ma'am.
Okay, very good. So here, this is your voltage triangle. Similarly, impedance triangle, how I will draw? This one is R. This one is what?
XC.
This one is your XC. Okay. This one is your, how much? XC minus XL. I am taking only the magnitude, don't worry. This one is your XL. So this vector will be equal to how much? Z. This one will be your theta. Here theta is what? Here theta I am taking it as negative. Okay, because this is my reference axis. Understood all of you or not? Tell me. Clear to all of you?
Yes, ma'am.
So now if you are clear, then you tell me what will be the value of Z from the impedance triangle. Tell me. Yes, tell.
R minus J XC
R minus J, how much?
XC minus
minus XL. Very good. Okay. That means Z is present at an angle, how much?
मैं माइनस थीटा डिग्री
Very good.
मेरा
Minus
माइक म्यूट था मैं
theta.
तब से बोल रहा हूँ
हाँ बोलो बोलो क्या 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 बोलो.
मैम मेरा माइक म्यूट था और मैं तब से जेड का वैल्यू बोल रहा हूँ
Okay, okay. हाँ ठीक है ठीक है. So Z is present at an angle of how much degree? Minus theta degree, right? So now, if I will tell you I is equal to I plus J0, yeah, this one I am taking it as the reference, that is I at an angle 0 degree. Z is equal to R minus J XC minus how much? XL.
एक्सेल
Z is present at an angle of how much?
माइनस थीटा डिग्री
Minus theta degree. So V will be equal to how much? Tell me. V will be equal to how much? I into Z, that is equal to I at an angle 0 degree multiplied with Z at an angle of minus theta degree. So this is IZ at an angle of how much?
माइनस थीटा डिग्री
Minus theta degree. So from here you can conclude that voltage is what? Lagging the current, or the current is what? Leading the
बाय द
voltage by an angle of
थीटा डिग्री
theta degree.
थीटा डिग्री
Okay. Clear? All of you are clear? So we can do problem. 2 problems we can do. We have time. Written all of you or not? First tell me. All
Yes,
of you have completed or not? Completed? Okay. Calculator रखो पास में. Problems. This class, tomorrow class, only problems we will do. We are having a coil of resistance. I will not detect all the thing. I will having less time, so I will draw the circuit. Okay, you draw the circuit. For this circuit, coil of resistance 12 ohm, inductive reactance XL equal to 25 ohm, capacitive reactance XC is equal to 41 ohm. Okay, here we are providing 230 volt 50 hertz supply. Using phasor algebra only. You have to use phasor algebra. Using phasor algebra, you have to find first bit circuit impedance. Find out circuit impedance. That is obviously it is asking to find out the value of Z. Then second bit current. Then third bit power consumed. These 3 find out. इस AC circuit से I will do 10 problems minimum. 10 problems if I will not do, your fundamental will not be clear at all. 10 problems if I will do, you will be master in AC circuit. जो भी problems आ जाएगा एग्जाम में तुम कर सकते हो. So 10 problems I will do, understand all of you. ऐसा नहीं कि हाँ मैडम प्रॉब्लम्स कर देते हैं, हम लोग ऑनलाइन में जाकर के कुछ और काम करेंगे, फिर मैडम तो शेयर कर देते हैं, वीडियो बना देते हैं, वो यूट्यूब में अपलोड हो जाता है, सब पढ़ लोगे. ऐसे मत करो. अंडरस्टैंड, आस्क मी. You have to use phasor algebra here. ठीक है? You have to use phasor algebra. Yes, done it. कितना तक किए हो बोलो. What is the impedance? Tell me first.
Ma'am, 12 minus 16J.
12 minus, who answered? I should know. Who is answering? Tell your name.
Ma'am, Vaishnavi.
Vaishnavi. Always Vaishnavi will answer. Rest answer. Z is equal to R plus J. What is the formula? XL minus
J XL minus XC.
Vibhu Kalyani, have you done?
Yes, ma'am, doing.
Okay, very good. 12 minus how much you have got, Vaishnavi?
मैं minus 16 वो बोला था.
16J.
16J ohm. This much?
Yes, ma'am.
Okay.
Ma'am,
हाँ बोलो.
I use the formula R minus J XC minus XL.
You have
मैम
used.
minus 16 होना चाहिए था ना, XL minus XC से.
हाँ बोलो बोलो. Let me clear. What you are? हाँ,
Ma'am, I use the formula R minus J XC minus XL.
You have used the formula XC minus XL. Okay.
Yes.
Okay. You use how much you are getting?
12 minus 16J.
12 minus 16J. Same you have got, na?
वही सेम ही ना आएगा.
Say, हाँ, later clear. Whatever doubt. Yes. Are you getting the same answer or not?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So now what will be what will be your yes, next what you need to find out? You have found out the impedance. What is the magnitude of the impedance? What is the magnitude of the impedance? And what is the, yes, that is this impedance. Suppose I will ask you, this impedance is present at how much angle? How I will find out?
I have to convert it into polar form.
Yes, very good. Convert it into polar form. Convert it. You will see definitely. Listen here, how the concept will, your concept will be clear. Find out the J at Z, and then I am telling you. Find out the value of Z. I am telling you.
20.
नहीं. Convert करो, Vaishnavi. You convert this rectangular form to polar form directly from the calculator. Convert.
Okay.
Amish, are you doing?
Yes, ma'am, trying.
Shuprashad, Bujhela, Saubhagya,
Yes, ma'am.
Saurav, you understood? Samriddhi, Saurav, Sayan.
Yes, ma'am.
Okay. Now convert it. Are so much time you are taking to convert?
मैम थीटा minus 53.13.
अब तुम मुझे पहले बोलो मैग्नीट्यूड बोलो, उसका तो डायरेक्टली मैग्नीट्यूड और थीटा आ जाएगा.
20 at an angle 53.
20 at an angle how much?
53.13.
नहीं 20 एट एन एंगल कभी भी 53 नहीं आएगा, -1 आएगा।
मैम
minus 53.
-53.
माइनस को क्यों छोड़ देते हो?
मैंने
माइनस तो
बोला ना
important है।
माइनस, मैंने बोला था।
Directly from the calculator you will convert this one, you will get it as minus. Are you getting it or not? Tell me.
Yes ma'am.
Huh?
Yes ma'am.
All of you are getting?
Yes, ma'am.
Yes, ma'am.
Yeah, I have forgot to say upload the video to convert. For that purpose, you are not able to calculate or not? I do not know. I have explained, giving you the syntax. So, what is the magnitude? Magnitude of Z is your 20 ohm, right?
21.
Okay. Now, this is your impedance. Now, how to find out the current? Listen here. How to find out the current? Pehle, first you understand everything. I am sharing the board. You will copy it down. Don't worry. So, V is equal to how much? V is my 230 volt. This is the reference value we will take. Then this is 230 volt. What I will write down? This is plus J0 volt. Okay. I have no information about the current, but I have information about the voltage. So voltage, I will take it as the reference one. Understood all of you? I don't have any current information, but I have voltage information with me. I will take the voltage as the reference. Okay. Let me calculate the value of the current. How I will find out the value of the current? Tell me. Current will be equal to how much? Using phasor algebra, V divided by Z. So this one will be equal to how much? This is in rectangular form. If I will calculate in the polar form, this will be V
230 less than 0 degree upon
At an angle.
at an angle. Yes, ma'am. Sorry, ma'am.
Rectangle.
लेस देन वो भूल जाओ, वो पढ़े थे लेस देन ग्रेटर देन, वो जो छोटे जो क्लास 4-5 में, अभी नहीं, अभी ग्रेट एंगल एट एन एंगल. सो V by Z is equal to how much? This is equal to 230 at an angle how much? 0 degree divided by Z
12
is
plus
equal to,
J6.
नहीं 12 plus J16 क्यों करोगे? पोलर में कन्वर्ट करो. You have to do the
20,
division operation.
20.
So
20,
you have to
20,
keep both
20
the
at
terms
an
in the phasor notation, polar notation. 20 at an angle minus
63.13 degree.
यहाँ पर कैलकुलेशन करो, एक इंपॉर्टेंट कंक्लूजन तुमको मिल जाएगा. करो, ये दोनों डिवाइड करो.
11.5 at an angle minus 53.13.
अरे तुम लोग इतना जल्दी कैलकुलेशन कर लिए. कितना कितना बोलो? 11.5
at an angle of
at an angle of
53.13.
53.13 degree. Okay. Here you see one thing. My voltage is present at an angle 0 degree. Current is present at an angle how much degree? 53.13 degree. So from here, what you conclude? Tell me.
Current leads the
Leads.
Current is leading the voltage. That means not by an angle exactly 90 degree. It is leading the current by an angle of how much degree?
53.13 degree.
53.13 degree. That means this is a RLC series circuit, but it is behaving as what? It is behaving as what? Tell me. Current is leading the voltage implies this is which type of a circuit? Huh? Current is leading the voltage is in which type of a circuit?
capacitor.
तुमको ना एक एक पूरा मार पड़ेगा तुमको. कितना करंट इज लीडिंग द वोल्टेज? करंट इज लीडिंग द वोल्टेज. हाँ बोलो, बहुत जन को पता है, बट यू नो कैपेसिटिव सर्किट. Okay, this is a capacitive circuit. Even if it is having a resistance, even if it is having an inductance, but still the circuit is behaving as a capacitive circuit. Why? Here you see capacitive क्यों है? Because तुम्हारा देखो XC 41 ohm है, XL है तुम्हारा 25 ohm. So here from here you can also able to know that the circuit is behaving as capacitive. Clear to all of you?
Yes, ma'am.
नेक्स्ट क्लास पूरा पढ़ के, नेक्स्ट क्लास मतलब कौन सा कब है? डे आफ्टर टुमारो. डे आफ्टर टुमारो पूरा स्टार्टिंग फ्रॉम एसी सर्किट विथ आर टू आरएलसी सर्किट विथ फेजर अलजेब्रा, पूरा ए टू जेड पढ़ना. Past 15 to 20 minutes, I will ask question randomly from your row, according to the roll numbers, not serially, randomly.
Okay.
I will ask. Then after that, I will switch over to problems. पूरा पढ़ के आना इतना.
Yes, ma'am.
Don't think that मैडम ऑनलाइन में करेंगे पूरा. Next class completely. Next class at what time I am having? 1 to 2 ना. 2 को मैं extend करके 2:30 तक ले जाऊंगी. पूरा पढ़ के आना. Fast 15-20 minutes I will ask questions. Okay, चलो.
Thank you, ma'am.
थैंक यू मैम.
मैम वो जो स्टार्टिंग में आपने कुछ अटेंडेंस